Parity bits. A parity bit is a type of check digit, and we have discussed check digits in a previous video. Now, it is an extra bit added to a data message, and this data message is made out of binary data. So the data message is made out of ones and zeros, and this extra bit is added before the transmission at its origin, before the data is transmitted. And upon transmission, what happens is the data is then scrutinized at the receiving end to determine whether an error has occurred in transition. Now, when we describe it in more detail, this statement will become more apparent, or rather the meaning of this statement will become more apparent. And we have two types of parity bits. We have even parity, and here an extra bit is added to construct a string with an even number of ones. Now, as we go through the video, we will see what we mean by even parity. And we have odd parity, and here an extra bit is added to construct a string with an odd number of ones. So in this video, we will concentrate on even parity. Now, suppose we have now Alice, and what she wants to do is to transmit this particular string 10101010. So she wants to send this string to someone called Bob, and this string has 7 bits: 1, 2, 3, 4, 5, 6, 7. And this particular string has 3 ones in it. There's the first one, second one, third one. So this string has an odd number of ones. Now, in even parity, a string has to be created with an even number of ones, and currently this string has an odd number of ones. So what we do to fulfill the criteria of even parity is a 1 is added to the end of the string before transmission, and this extra bit is the parity bit. So this 1 is added to the end of the string, so now we have 1, 2, 3, 4 ones, so we have a even number of ones, and this 1 which has been added is called the parity bit. So, as a result of adding the 1, we have an 8-bit string, 1, 2, 3, 4, 5, 6, 7, 8, which has an even number of ones. Look, 1, 2, 3, 4. So now, this 8-bit string, which includes this extra parity bit, is passed to Bob. And here it is, the string with Bob, with the extra parity bit. And at Bob's end, he makes a calculation to determine the parity bit. And he has calculated that the parity bit will be 1. And this 1 here matches the 1 that Bob received. So we will say that the the string was correctly transmitted. So the parity bit is helping us to determine whether the string sent by Alice was correctly transmitted. Now let's look at another example of even parity detecting correct transmission. We have here Alice again, and she wants to transmit this particular string, which has 7 bits in it: 1, 2, 3, 4, 5, 6, 7. And now this particular string has 2 ones in it: 1, 2. So this particular string has an even number of ones. Now remember, in even parity, a string has to be created with an even number of ones. So, to fulfill the criteria of even parity, a 0 is added to the end of the string before transmission, and this extra bit is the parity bit. So, as a result of this 0 being added, we get an 8-bit string, 1, 2, 3, 4, 5, 6, 7, 8, which has an even number of ones. So we see the string has 2 ones in it. And then this 8-bit string, which includes the extra parity bit, is passed to Bob. And here we have Bob with the string, the 8-bit string here. Now, Bob does a calculation to determine the parity bit as well, and he finds that it is 0. This 0 here matches the 0 that he got, and we will say here that the string was correctly transmitted. So here the parity bit has helped us determine that the string was correctly transmitted. Now, detecting an error in transmission of data with even parity. This can only happen if one bit is sent and read incorrectly. What do we mean by this? So here, the parity bit is going to detect an error in transition. Right, so we have here Alice again. And she is trying to transmit this particular string with 7 bits, 10100000. Now, the string has 2 ones in it. For even parity, a string has to be created with an even number of ones. So we put a 0 at the end of this string here, and this extra bit is a parity bit. We get an 8-bit string with an even number of ones. So we can see that the string has 2 ones in it. And then this 8-bit string, which includes the extra parity bit, is passed to Bob. But this string passed to Bob has an error in it. So what happens here? Look, this 0 is now transmitted as a 1. And this is the string which was transmitted to Bob. So Bob does a calculation to determine the parity bit. And he decides that the parity bit should be a 1. Why? Because this is what Bob has, 1110000, and to make it even parity he puts a 1 at the end. Now this one here does not match what Bob received, so Bob calculated that he should have a 1, but he received a 0. So therefore we will say that the string was not correctly transmitted. So 1 bit was changed here, and we will say that the string was not correctly transmitted. So we have used the parity bit here to determine incorrect transmission of data. Now, only if 1 bit of the binary string is sent incorrectly, then the computer can pick up the error. Now here, there's going to be an incorrect message sent, but no error detected with even parity if 2 bits are transmitted incorrectly. What do we mean by this? We have Alice. She wants to send this string here with 7 bits. It has an even number of ones. So with even parity, a 0 is added here. So we get this 8-bit string with an even number of ones. And then we send here this string to Bob. But what happens when we send the string, or when Alice sends the string to Bob, is that 2 bits are incorrectly transmitted. We can see that here the 0 is transmitted as a 1, and this 1 is transmitted as a 0. So this is the string Bob receives. So Bob does a calculation to determine the parity bit. And Bob determines that the parity bit should be 0 with even parity. And so Bob calculates 0 and Bob received a 0. But actually what happens is, even though Bob calculated 0 and there was a 0 received, the message was actually incorrectly transmitted, but the parity bit did not pick it up. So if 2 bits are incorrectly transmitted, then the parity bit will not pick it up. Questions. An even parity bit has been added to the end of 3-bit binary codes to create the 8-bit binary codes below. Identify and explain which code contains an error. So we have code 1, code 2, code 3 with 8-bit strings, and the last bit here is the parity bit. So which one contains the error? Pause the video and see if you can work it out. Okay, this is the parity bit here, the 1. The last digit is the parity bit, and the code has 5 ones in it. But in even parity, you have to have an even number of ones. So this code 1 contains an error. Now in code 2, this last digit here is the parity bit. The code 2 has 4 ones in it. In even parity, you need an even number of ones. So code 2 does not contain an error. Code 3, the last digit is a parity bit. Code 3 has 4 ones in it, 1, 2, 3, 4. And in even parity, you need an even number of ones. So this code 3 does not contain an error. So it's code 1 which contains the error. Then the next question is explain how a binary code containing a parity bit can be read incorrectly without any errors being detected. Okay, pause the video and think. We have explained it before. You can go back and look at the explanation. Okay, it was this slide here. So can you see that basically the summary is if 2 bits are incorrectly transmitted, then the parity bit checker will not pick it up. So the message was incorrectly transmitted and the parity bit did not pick it up. You can pause the video and think about it. So that's even parity bits.